Hi, my name is Evan Boland, and I will be presenting on Physics 1, Lab 2, the motion of a falling object. The purpose of this lab was to observe the motion of a falling object and analyze its motion using Tracker. And then we had to build models in order to see the role that the weight force as well as the drag force played upon the object. This procedure was to pick an object, which I chose a pillow, and observe it falling slowly. And the reason I chose a pillow is because I knew that it would fall somewhat slowly so that the object would be easier to track. And then I had to graph this motion and construct computational models using GlowScript. And these computational models included the effect of gravity as well as drag force on the object. And then I compared the observe versus computational models, which you will see in the next few slides. There were a few fundamental principles that we needed to know in order to complete this lab. And one of those, once again, was Newton's second law. And this allowed us to be able to calculate our net force. And as you can see in the equations, the change in velocity divided by the change in time is the net force divided by the mass of the object. And this allowed us to also calculate the displacement, which is simply the change in velocity times the change in time. But also, in order to understand net force, we also had to understand two other forces. And these forces for the object were drag and gravity. So as you can see in that diagram, the force of gravity will be pulling down upon the object as it falls, and then the force of drag will be pushing up upon the object. And that net force is going to be equal to that force in gravity plus the force of drag. And gravity is simply how Earth's gravitational force affects objects. And this is calculated by the mass times the gravity constant, which is 9.8 meters per second. The drag force, however, is a different formula. And drag force is also known as air resistance, and it acts in an opposite force opposed to the relative motion of the object. And this is calculated by a coefficient, negative b, which I'll explain what goes into that coefficient in the next few slides, times the velocity, the magnitude of velocity squared. So for this lab, I chose a pillow and I dropped it from above my head until it hit the ground, and then I analyzed this within Tracker, as you can see on the screen. And this graph to the left is the graph of the observed motion in the y direction of the pillow dropping. As you can see, due to some human error, but also just because an observed object isn't going to be perfect, there are a couple divots that are a little bit off on this graph, but I will explain those in the next couple slides, as well as I will compare them to the computational graphs. So here's a look at a computational model that I made within GlowScript. And the only force acting upon the object in this code is gravity, as you can see with the g equaling to 9.8, and it's acting upon that mass of the pillow. And so this is the graph that you would get if that were the only force acting upon the object. And in this graph, you see the difference between the observed graph of the pillow dropping and the computational graph of just gravity acting upon the object. And as you can see, those endpoints are a little bit off, and I'll explain why that happened in the next couple slides. So here's a look at my code that I had to make in order to include drag force within my graph. And this is going to be a little more similar to the observed data that we just saw. And like I said before, the force of drag is calculated by negative b times magnitude of velocity squared, which is technically just 1/2 times the air density times the speed of the object times the constant times the surface area. And this air resistance is really important to include because it is why the observed data looks the way that it is. And I had to find that b experimentally, which I found to be about 0.0099. And this is included in the code as you see below. So here's the comparison with drag force. So on top, you'll see the graph that we had just seen. And then at the bottom, you will see including drag force. It almost is exactly the same as the observed data. In conclusion, the models with the weight and the drag force show the terminal velocity, but the models with just the weight force will not show true terminal velocity. And if the object were thrown downward, the terminal velocity would not be different because it's not dependent on the initial velocity. And finally, just a little summary. Some of my results might not have been calculated perfectly in my observed graph because of human error within Tracker, And that is why you'll maybe see a little bit of divots in those graphs. But other than that, I think this experiment showed a great difference between the drag force and gravity acting upon a falling object versus just gravity itself.